Hey gang, we're gonna look at solving the last problem from quiz number 2. So I have it projected here, and first we just want to pull. Whoa! Sorry about that. The first thing we want to do is we want to pull out all of the important information from this problem. All right, so you have a large crane that has a steel lifting cable that has a what's going on here? Diameter of 1.92 inches. Okay. The next thing that we have that might be important is this modulus of elasticity. The modulus of elasticity is 290,000 pounds per square inch. That's what PSI stands for. It's used to lift 4,333 pounds, and the unstretched cable length, I'm having a hard time talking, is 23 feet. Okay, 23 feet. So let's jot down what all of this information is, okay? So the diameter is, what are we saying here, 1.92 inches. We have the modulus of elasticity, which is that capital E, is 290,000 psi, which is pounds per square inch once again. It is used to lift up a force of 4,333 pounds. And the unstretched cable length, which we are calling that L naught, LO, is equal to 23 feet. The first thing I would do is I would get everything into the proper dimensions, meaning I would make sure all of my measurements kind of align. So we have pounds per square inch. We have a force that's measured in pounds, a diameter that's measured in inches, but then we have a distance that's measured in feet. So the first thing I would do is I would convert that 23 feet into inches. So 23 times 12 gives us an original length of 276 inches. Okay, so now we're all in proper units. So what do I actually want to find? Well, the problem's telling me to find the extension of the cable in inches. Okay. All right, so we want to find the extension of the cable length in inches. So we could use this modulus of elasticity equation that's using stress and strain. We're going to end up using that. We're going to use all of these different equations that we had listed in the previous part. Okay, so notice in the strain equation it is the amount of the stretch divided by the original length. I just wanted to highlight that. So when we're using that equation, it's finding the amount of the stretch. Okay, I'm sorry, this is the amount of the stretch over the original length there. So what can we actually find first? Well, we can use the modulus of elasticity to find the strain on it, all right? But the first thing that we want to end up finding is the stress, okay? So let me just get my tools right here. So first thing we can actually find is the stress, but the only way that we're going to find the stress first is if we know both the force and the area. Well, we don't know the area. It is a large crane steel cable with a diameter of 1.92 inches. Well, we can use that diameter to actually find the area, the cross-sectional area, which would be pi r squared. Okay, make sure you're plugging in the radius in there and not the diameter. So my equation is going to end up being pi times r, which is going to be half of 1.92, which will be, 0.96er. And I'm going to square that. So that's going to give me the area. Let me just do some magic math. I'm just going to use 3.14 for pi. You guys can use the actual pi button if you want to. It's fine. So squared times 3.14. That gives me a cross-sectional area of 2.89. 2.89 inches squared. Okay? So now that I know the area, I could take that and plug that into this equation for the stress of the object. So stress is equal to force. The force that I have is 4,333. I don't know why I'm having such a hard time with that number. Pounds per the square, the cross-sectional area, which we calculated as 2.89 inches squared. So if I divide those two numbers, that's now going to give me the stress of this object, which after plugging it into my calculator, I'm going to get 1,497.3 pounds per square inch. Okay, so I'm going to end up wanting to use that in my modulus of elasticity equation over here now. Okay, so we're going to take this number and we're going to plug it into this equation right here. So we already said that my modulus is 290,000. 290,000. The stress that I have is 1,497.3. That's what we just calculated in the previous part. And we're going to use this in order to find the strain, okay? So I'm going to do a little bit of math. Whenever you guys are solving for something in the denominator, just some basic algebra, make sure you get it out of the denominator first, okay? And now you can solve for the stress that this is experiencing. Okay, so I'm going to end up doing 1497.3 divided by that modulus there. I put that comma in the wrong spot because I'm a goof. And I get a strain that is a pretty small number, 0.00516. Okay, so that is my strain that I am experiencing. So what am I going to do with that? I'm going to take that and I'm going to plug this into my strain equation right over here. And that's going to end up allowing me to solve for this distance that it's stretched. So now I have 0.00516 is equal to the stretch, which I don't know. It's a Greek letter that I'm not very good at drawing. It kind of looks like an apple by my drawing. Divided by 276. That's how many inches the original length of it was. Solving for the stretched amount. That looks like a cherry. I'm going to multiply by 276 on each side. And that means that the stretch of this object is going to be 1.425. And what's the unit on that going to be? It's going to be inches. That's how much it is actually stretching. So that steel cable stretches actually a pretty significant amount when you have 4,000 pounds pulling on it. Okay? I hope that was helpful. Thank you guys.